This is the screencast for section 4.2, example 7. We're going to look at kind of going backwards from the derivative. So first, let's take a look at this corollary. Functions with the same derivative differ by a constant. So in other words, if f prime equals g prime at each point of an interval I, then there is a constant c such that f of x equals g of x plus c for all x in I. In other words, like if f of x is x squared, g of x could be x squared plus, pick your favorite number, sure, 17, and they would have the same exact derivative because that constant's derivative is 0. So we need to keep that in mind when we go backwards from a derivative. So let's look at example 7. Find the function f of x whose derivative is sine of x. So f prime of x equals sine of x, and whose graph passes through the point 0, 2. Alright, so we'll keep that in mind. If f prime of x equals sine of x, f of x then was negative cosine of x plus possibly some constant, and I don't know what that constant is yet, but we're going to find that out. We do know that it passed through the point 0, 2, so I'm going to plug in 2 for y and 0 for x to solve for c, and I get that 3 equals c. So that f of x was negative cosine of x plus 3. This is the equation of the graph whose derivative is just plain old sine of x, but also passes through the point 0, 2. The now try problem, number 35, says find the function with the given derivative whose graph passes through the point P. Okay, so the derivative, f prime, is, well, I'm going to rewrite this, and I'm going to say that that is negative x to the negative 2. So that means f of x was, okay, thinking backwards here, whose derivative became the exponent negative 2? Well, that was exponent negative 1, so I'm going to add 1 to the exponent, which was negative 1. And before, I multiplied by that negative 1, so now I'm going to divide by that negative 1. And so it just leaves me with plain old x to the negative 1, and then don't forget a plus c. So checking that, okay, the derivative of x to the negative 1 would be negative 1 x to the negative 2, which is what the derivative was. Okay, so now I just got to find out what that constant is. I'm going to plug in 1 for y, 2 for x, and solve. And I get that the constant is 1/2, so f of x was originally x to the negative 1 plus 1/2, or 1 over x plus 1/2. That is the function whose derivative would be negative x to the negative 2, or negative 1 over x squared, and also passes through the point 2, 1.